Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is differential equation based on the order. The differential equation is classified based on the type, order, linearity and homogeneity. In this video, we are going to concentrate on the types that are based on the order. A differential equation is nothing but a mathematical equation that relates some functions with its derivative. In real-life applications, the functions represent some physical quantities, while its derivative represents the rate of change of the function with respect to its independent variable. Okay, let's now learn about the order and degree of differential equation. We classify the differential equations in various ways owing to the variety of life around us. Innumerable types of functions and hence differential functions to model the innumerable physical processes are possible. We are classifying the simplest of them being on the basis of the order and the degree of the differential equation. This is an important categorization because once grouped under this category, it is very straightforward to find the general solutions of this type of differential equation when it comes under the order. The method of finding the general solution of a differential equation of the second order can be extended to find the general solution of differential equation of the nth order. Okay, you will encounter this if you go for higher studies in mathematics. So let's start with the basics of the order and degree of the differential equation. I'd like to give you a detailed information about the differential equation first. Here is the general differential equation in two variables where f of x, y, y dash, y double dash, etc. is a function of, this is a function of x, y, y dash, y double dash and so on. And you should know what is x. X is nothing but the independent variable. And y is the dependent variable. It changes when depending upon the x. Whatever change happens in x, it will affect the y variable. Y dash, y double dash and so on is the first order derivative of y. Second order, this is the second order, and in case if you have more than this, you can say that based on the order. First, second, third derivative and so on. And you know obviously c is some constant. Now let's see what is order and degree of a differential equation. Order of a differential equation is nothing but order of the highest order derivative that is involved in the differential equation. The degree of the differential equation is nothing but the exponent. Obviously you would have learnt about this in the polynomial, degree of the polynomial equation in that and all. Okay, the degree of the differential equation is nothing but the exponent of the highest order derivative involved in the differential equation when the differential equation should satisfy the sum of the conditions. Let me list out the conditions. There are basically three conditions a differential equation should satisfy. All the derivatives in the equations are free from fractional powers and it should be positive as well as negative if any. And the second important condition is there is no involvement of the derivatives in any fraction. And third important condition a differential equation should satisfy is there should not be involvement of higher order derivative as a transcendental function, trigonometric or exponential. The coefficient of any term containing the highest order derivative should just be a function of x, y or any lower order derivative. Okay. If one or more of the the functions that I have mentioned, transcendental, trigonometric, exponential, the conditions are not satisfied by the differential equation, it should be first reduced to the form in which it satisfies all the above conditions which we discussed just now. An equation has no degree or undefined degree if it is not irreducible. Can you follow so far? Okay, the determination of the degree of the given differential equation can be very tricky if you are not well versed with the conditions under the degree of differential equation is defined. So, learn all the three conditions before solving any question that is under the degree, and you should master the technique of calculating the degree of the given differential equation. Let me show you some examples. Then you can identify those types of questions easily. Here is the first example. We are supposed to find the orders. Please look at the equation carefully. For a differential equation represented by a function f of x, y dash is equal to a constant, the first order derivative is the highest order derivative that has involvement in the equation. So the order of such differential equation would be 1. In similar way, let us work out this example too. We have 3 terms on the left side of the equation, and you should look at the degree of this one, dy over dx, and d square y over dx square. So what would be the order? Yes, the highest exponent, yes, 2. Okay, now the exponent highest is the degree, and we have first derivative and second derivative. So the order would be 2 here, and degree is also 2 here. Does this make sense to you? Okay, let me give you one more example. In some cases, you may not see one of the term, but you should understand the term that is not mentioned. I'll give you one example like that. Please have a glance over this example. We have x dy over dx d cube y dx square. But we don't find any term with d square y over dx square. So it doesn't mean that there is no term like that. Actually, it is nothing but 0 times d square y over dx square. So the highest order and degree of this equation is 3. Am I right? Because the third derivative was given in this equation. So the order is going to be 3. So far we discussed examples which are straightforward. Now let us take one example which has a square root. So what is the order here? First derivative is here, second derivative is here. If you want to get rid of the square root, you have to square on both the sides of the equation. Even if you square, there will be a square outside this only. It will not change into d raised to 4. Please notice this point. So the order for this equation is just 2 because we have the second derivative. Some students may mistake that on squaring both these sides, they will get every term under the radical as such here without the square root sign. And on the right side, by squaring, sometimes there are chances for the students to mistake that d square y will change into d raised to 4y. So that is the very common mistake students make. So please try to avoid that. So even if you have a radical sign, you should notice only the derivatives given, first order, second order. So this is the order number 2. Okay, let me take one more example in finding the degrees. Please have a glance over this example. 3y square times dy over dx the whole cube minus d square y over dx square, which is equal to sin x square. The highest order derivative involved here is of order 2 because second derivative is given, and its power 1 in the equation. So you can say that the order of the differential equation is 2 and the degree is 1. You should look at the exponent of the highest order term. This is how we find the degree. Does this make sense to you? Here is another example. Please have a glance over this. This equation involves fractional powers, and we must first get rid of them. How do we get rid of the square root? As I said already, we have to square the equation throughout. I mean squaring both the sides of the equation. So on squaring, you will get 1 plus dy over dx the whole square equal to y square d cube y over dx cube the whole square. Am I right? Now we can clearly make out that the highest order derivative is of the order 3 because third derivative is here. The order of the differential equation is 3 and its power is going to be 2 because on squaring we will get rid of the radical sign. So we will get an exponent 2 for the highest order. Therefore, the degree of the differential equation is 2. Does this make sense to you? Okay. Please have a glance over this example. So what would be the highest order derivative and the degree for this equation? Here, the highest order derivative is of the order 2. Am I right? There is no other order higher than this. And it has no involvement in any other function. Am I right? So, the order of the differential equation is 2 and it has just an exponent 1. So, the degree is going to be 1. So, this is how we identify the order of the derivative, order of the equation and degree of the differential equation we get. So, what are the conditions you should look at? You should first check whether the given equation is a differential equation or not. And then you have to find the order. the highest derivative given in this equation, and you should check whether it has any involvement with the other functions in the given equation. After that, you have to check the highest degree exponent of the highest order term we found. So this is all about the order and degree of the differential equation. In case if you have any query regarding this topic, please let me know. See you in the next video. Have a great time ahead.